Hello mathematicians, this is the final lesson of our one variable equations unit, and your objective is that you will be able to solve a one variable equation and recognize if the equation has a special solution or not. So these are the types of solutions that we can have. One solution is the most common type when you solve an end with a variable equaling a number. For example, x equals 5, t equals -2. These have been the equations that we have dealt with from lessons 1 through 5. So this is nothing special. You don't have to write one solution when you get a solution. These have been what we have seen throughout the entire unit, so nothing has changed there. What's new this unit is we are going to introduce two different types of solutions, and one being infinitely many solutions, or all real numbers, and that is if the variable term cancels out and you end up with a true statement, then the answer is infinitely many solutions or all real numbers. There are several ways that you can write it. So I just want to show you all those different ways, because when you go to find your solutions or go and find your examples, just to be aware that they could be listed differently. For example, you end the equation and you get 5 equals 5. Well, that's true, but I don't have a variable. So the variable doesn't equal a number, but 5 equals 5, so that would be all numbers work. Or 0 equals 0, or -6 equals -6. Conversely, sometimes you can get something that has no solution. There is no number that works for that equation. So if the variable terms cancel out and you are left with a false statement, then your answer would be no solution. So for example, you end with 0 equals 2. Well, that's not true. 0 and 2 aren't the same. And you don't have a variable, no solution. -6 equals 6, that's not true. So your answer would be no solution. So notice the key phrases that I want you to notice in both of these new definitions. If the variable term cancels out. That is the most important thing to understand when we're talking about special solutions. Because a lot of times once we introduce these special solutions, as soon as the problem gets challenging, students just write no solution. But that's not the case. If you have a variable throughout your solving steps, it's going to have a solution. It's only if and only if the variables cancel out. So let's take a look at some examples. And our first step always is to make sure both sides are simplified. So we still have -8 over here, but we have some like terms to combine. So -6 plus 6, well, if I have $6 and I spend $6, I have $0 left. I have no variables. My variable term canceled out. So that means it's going to be a special solution. So I asked myself, does -8 equal 0? Well, no, because if you have $0 in your bank account versus being in the negatives, that is very different. So no, that is a false statement, so your answer is no solution. And that is the answer. So I'm looking for these words. Okay. Yes, I need to see this, but this is the answer. All right, let's take a look at number 2. There's nothing to simplify on either side, so I always want to move my variable first. So I'm going to move this -2k, so I'm going to add 2k and add 2k. Well, -2k is 0, so I bring down my 1. I bring down my 1, and -2k plus 2k is also 0. The reason I want you to move your variables first is because these special solutions are based solely on if the variable cancels out. So you can do all these crazy steps, and then you get to the end and realize your variable canceled out, and you could have just stopped it. So always move the variables first. You'll end up doing less work, and you'll be able to know right away if it's a special solution or not. So my variable canceled out. Is this a true statement or is it false? Does 1 equal 1? Well, yeah, if you have $1 and your friend has $1, you have the same amount of money. So you have infinitely many solutions. All right, so I do want to take a moment to kind of show you how this works. You don't have to do a check step on your mastery checks or the test for this particular lesson, but let's just try -8. Let's see if -8 works in this equation. So -6 times -8 would be a positive 48, and 6 plus a -8 would be a negative 48. Well, 48 minus 48 is 0. So it still doesn't work. What if I tried 0? Well, -6 times 0 is 0. 6 times 0 is 0. Still doesn't work. What if I just try a random number? 8 equals -6 times 2 plus 6 times 2. -12 plus 12. -12 plus 12 is 0. So it still doesn't work. So you can try any number you would like, and it doesn't work. Now, conversely, let's take a look at example 2 and just try some random number. 3. Let's try 3. So -2 times 3 plus 1 equals 1 plus -2 times 3. So -2 times 3 is -6 plus 1 equals 1 minus 6. That'd be -5 equals -5. So that works. Let's pull another random number out of our hat. Let's go -7. That would be a positive 14 plus 1 equals 1. -2 times -7 is a positive 14. 14 plus 1 is 15. 14 plus 1 is 15. So any number that you pull out of the hat is going to work in this equation. That's why there's infinitely many solutions, and that's why we can't really check our work, because there's too many numbers to check. Same with no solution. Like, there's no point in checking those because nothing's going to work. All right. This lesson, not only are we adding some new solutions in it, it's also a review of past lessons in this unit. So I look at this, looks like I need to distribute before I do anything else. So -6 times 1 is -6. -6 times b would be a positive 6b. We still have that -2 hanging out there, and 6b minus 8 on the right. I'm not fully simplified on the left. I have constants to add together, so -6 plus a -2, same sign, add the numbers, keep the sign. So I have -8 plus 6b equals 6b minus 8. I always recommend moving the variable first, so subtract 6b, because when you do that, you can see right away that your variable cancels out, and so you know it's going to be a special solution. Is this statement true? If I owe somebody $8 and somebody else owes somebody $8, they owe the same amount of money. So yes, -8 is a true statement. So it is all real numbers or infinitely many solutions. I accept both. I just want to make sure that you understand that it can be written differently in different places. And finally, I'm not fully simplified on the right. I have like terms to combine together. So 5 plus 2 is 7n plus 4. Subtract 7n. And you can see that it cancels out right away. So ding, ding, ding. We're going to have a special solution because there is no variable left. Does 7 equal 4? Absolutely not. So the answer is no solution. And that's it for today. Just be aware that the mastery check, not all of the questions are a special solution. So you have to go back to the past 5 lessons and also add this part in and be able to recognize when something is just a normal equation and when something has a special solution. As always, happy mathing. Don't forget to go find a couple of examples of some special solutions. Let me know where you find them.